This video is on the quotient rule question, so we are going to solve a problem like this. So the first thing is you need to know the rules for exponents, right? So it asks you to write only using positive exponents. So I typed out a few rules. The first one is x to the a times x to the b, meaning they have the same base but different exponents. A and b are just numbers. We could call a 2, 2 and 3. Oop, 3. But I'm just leaving it as a and b just to be general about it. And we can do an example if you'd like. So x to the a times x to the b is x to the a plus b. And then x to the a to the b power is x to the a times b. And let me give you a quick example of why that is. So if we have x to the 3 squared, x to the 3 squared, well, what is x to the 3 squared? That is just x to the 3 times x to the 3, right? Anything squared is just it times itself. So that's writing out x to the 3 squared. And then you go back to rule 1 now, which is the sum, which is a plus b. So this is 3 plus 3. But 3 plus 3 is the same as 3 times 2. So that's why rule 2 holds, is because when you square it, if this were to the 3, that, we'd have an extra times x to the 3, and that's the sum of 3 plus 3 plus 3, which is 3 times 3, right? And the final one is that x to the negative a equals 1 over x to the a. And if you know these rules, you should be able to solve this problem. So let's take a look. So let's write this out. 5p to the 4 times 2p to the 3 to the negative 3, and then times minus 8pp. Okay. So the first thing I'm going to do is, well, there's many things. So the first thing I'd like to do is change p times p. What is that? Well, that's p squared, right? So let's change that. This is going to be rewritten as a fraction because it's negative, so we can put that on the bottom and take away that negative. And that'll be 1 over this. And now let's, I'm just going to write these on top, because we're just multiplying, so these are on the numerator of this fraction, right? So we have this so far. And we're going to simplify here. So we can combine these on the top, so that equals, we can multiply the coefficients. So 5 times negative 8, well, 5 times 8 is 40, so negative 40. And then the p's are going to multiply, and we're going to be using the multiplication rule, so we're going to add the exponents. So 2 plus 4 is p to the 6th. And then on the bottom, we're going to be multiplying the exponents, but we also have to cube the 3. So it's 2 to the 3rd power times p to the 9th power. And 2 to the 3rd, we can change that to 2 times 2 is 4 times 2 is 8. Okay? And then, well, we just saw that we multiplied 5 times 8, so that's just going to be 5 on top. That will cancel. So we're just going to have 5p to the 6th. 5p to the 6th, because of the 8 cancels. This is 5 times 8, so the 8's cancel. And on the bottom, we have p to the 9th. And because this p on top is a lesser power than the one on the bottom, if the same thing I said about rule 3 here. The same can be done if you have x to the a, that equals 1 over x to the negative a. Okay, so it equals 1 over x to the negative a, kind of the opposite. So that's actually what we're going to do here. We're going to say, well, that equals 5 over p to the 9th times p to the minus 6. So we just put this on the bottom and change it to minus 6, and well, we have a 5 on top. And again, we're going to refer to rule 1. A times b is a plus b, except there's a negative here, so it's going to be a minus b. So 9 minus 6 equals 5 over p to the 9 minus 6 is 3. So this should be our final answer. You know, just do one step at a time. Make sure you're following on the rules, and you should be able to get this out. So let's take a look at our answer. Oh, I might have dropped a negative in there. Yeah, I think I dropped the negative here, so I just messed that up. So there should be a negative there. But negative 5 over p to the 3.